Sorry, Alhamdulillah. Before starting the
Yes.
lecture, I would like to ask the question about the quizzes that you are going to organize tomorrow. Can you give some detailed information about the quizzes, or will you send an email about it?
Yes, I will.
Okay.
But I think your tutorial teachers should have been told you some information already.
Yeah, she gave some information, but about the structure and the type of the question and the topics that the question will.
Okay, we'll talk at the end of the class.
Okay.
Okay. So yesterday we talked about some economic aspects, factors that are affecting the matrix acidizing. And can you see the slide? We talked about the economic limits, what is acceleration, what is an increase in reserves, acceleration when we increase the production, almost without increasing the reserves. So we produce the same reserves but faster and earlier. Increasing reserves is when we, by the acid stimulation, we achieve some longer production from the well and increase accessibility, increase the drainage area of the well and produce more than we estimated before as a ultimate recovery for the same well or group of the wells. So again, as we talked before, when we do the candidate selection, because candidate selection is the first step and is one of the most important steps, because it is very important to choose or to select a appropriate candidate for the matrix stimulation, because again, we are going to spend some investments on this operation, and we have to make sure that these spendings, these investments will pay off as soon as possible, and it will be lasting long enough to approve or to confirm the profitability of these operations. Therefore, we have to look at every parameter that controls the well production. It is not for the matrix stimulation, the subject is reservoir performance, inflow performance of the well, but considering only improvement from the inflow performance would be a wrong approach, because
Müəllim çıxdı.
Deyəsən, hə.
Can you hear me?
Yes.
Sorry, I got power cut and so let's continue. So we have to check every parameter that controls the well production, and inflow performance is only part of this, which is affected by formation damage and subsequent matrix acidization. But we have to take into account, we've been talking about that last lectures as well. We have to make sure that the improvement or increased production will be handled, or it will not be limited by the well construction or tubing size or any other obstructions in the outflow system or surface equipment that will not be able to handle this increase in production. And so our estimation of the additional production, our estimation of gain will be just masked by those obstructions, by those limitations. Therefore, the potential gain should consider both inflow and outflow performance, although we are, by the matrix stimulation, we we affect the inflow performance only.
Sorry Muhammed. Slide
Yes.
görsem
Görsem için şey verememişim. Sorry. Okay. Can you see now?
Yes.
Can I take it as yes?
Aha görsen Arman.
Okay. One sec, I will share again. There is something wrong. Okay. So, sorry. So therefore, again, all the production system from the reservoir to the separator or storage facilities must be considered when predicting or evaluating the possible increase in wells production rate, as well as in economical effect of economical effect of the simulation. Here is some minimum candidate well selection criteria that are kind of a rule of thumb. It's a hydrocarbon saturation, so it should be above 40 or 50% respectively for oil and gas reservoir. So we are aiming enough oil or gas reserves to be extracted. Water cut is preferably below the 30% because matrix stimulation will be affecting the reservoir rock, and so this may trigger even higher water cut. And permeability should be above 20 millidarcy for oil reservoir or gas, 1 millidarcy for gas reservoirs. These kind of again, a rule of thumb guidelines, but of course, the final decision should be made from the very thoroughly study results, and there will be some more study of the well production specifications, wellbore specifications, etc., etc. And the reservoir pressure is depleted below the 70%. So it's again, too much depleted reservoir may not provide enough or sufficient improvement in oil, incremental oil. So it should be taken into account that the expected potential increase may not be achieved because of depleted reservoir. And of course, production system, total production system must have at least 20% spare capacity in case of unexpected or expected increase, larger increase in the production incremental. So from this example, we can see that we have a reservoir or a field with the different permeability zones. KH, we call it, it's called KH zones, permeability by thickness, and it's a we have a low permeability, medium permeability, and high permeability. And when we select a candidate, we have to consider the wells that, for example, in this example, it says possible stimulation candidates are these ones because they have not produced too much, so there is a possible potential for the additional oil or more oil left in the drainage area of these wells. On the other hand, we have to consider, well, this is first kind of impression, but if we look at further, this well you can see is only is in the low permeability zone, and we have to first identify what is the reason for low permeability. Is it geological reason or is it because of formation damage? And also this well is located between the 4 wells that have been producing for some time, and that will reduce the drainage area of this well, and hence will reduce the remaining or reserves that associated with this well. So therefore we have to consider more study about this well and this well as well. But this well, you can see in one side it's a kind of free, and there might be even more remaining reserves. And if we compare to other wells in the same zone, we can see that those wells have been producing for some time, and so this well can also produce the same amount of oil, and maybe it's just drilled or other reasons, or maybe there is no artificial lift installed. So, and therefore it is very important to get all this possible available surveillance data for identifying or selection of the treatment, and put in correct timing or correct sequence of those wells, which one should be first treated and which one should be treated Next. Also, we have to consider here the results of PLT to see how these zones are contributing results of pressure temperature monitoring. In nowadays, many companies and on many fields and wells are using permanent downhole gauges to control and DTS systems, delayed time, so temperature surveillance, which transfers pressure and temperature through the wellbore from the downhole permanently or continuously, so you can identify any problems associated with the well performance. And results of well testing, results of any kind of testings carried out on the wells regularly. So therefore, we have to consider which well will benefit and will the well benefit from the stimulation. And for that, we have to, as I said, identify, is it because of formation damage or is it because of just lithological and geological reasons. Another question is that what type of formation damage it is and where it is, where its location. Is it in the perforations? Is it in the near wellbore? Or is it due to the wettability change or relative permeability change? Or it's a pore blockage? The questions like sand control measures in place have a kind of dual approach. Like if we have it in place, it might be also kind of a factor affecting the low productivity, or if we do the stimulation, it might trigger because of cement material dissolving, it might trigger some sand production, and will the well and will the operators ready to handle this sand production from the well. So the equipment in the tube, in the wellbore and on the surface is not affected or damaged. Another question to answer here, is simulation feasible at all? Or in other words, another approach, how the well conditions appropriate for that? Do we have a good conditions in the well, like no leakage in the tubing, or the other problems with the tubing, or any wellhead equipment? Will it allow to inject this acid composition into the well and without any harm to the well and the probably environment? Logistics are very important. Can we bring their the equipment, required equipment? Can we bring their required specialists? Can we obtain the required chemicals or any other equipment that are required for this job? Also, it is important to select what type of simulation we are going to have. It means what type of chemical composition we are going to use, and we learned that it mainly depends on what is the aim of the treatment. Is it sandstones or carbonates? Do we need a pre and post flushes? Well, we almost always need pre and post flushes, but what is going to be a composition of pre and post flushes to remove the first to clean the pre-flush and post-flush are respectively done before and after the main acid job. One for cleaning the pores and preparing the reservoir for main acid job, and the another one post-flush is the assumed to clean the reservoir formation from the reaction precipitations or reaction material, or to move those materials, those precipitations away from the wellbore, so the nearest zone of the wellbore is clean. And also we have to identify the treatment volumes and rates, how much we should inject at which rates, and it will depend on, of course, the radius of the damage or the depth of the damage, and we should know the porosity and the how much that will dictate how much acid or pre-flashed and post-flashes are required to complete the acid job. And of course, a simulation design and execution is important, because this is a very important part. What kind of equipment we need, who is doing what, and the design includes also the choosing or preparing the compositions, etc., etc. And of course, as a final step, it is a simulation evaluation. What was achieved, what was done, how the achieved results are compared or matching the expected or estimated results. From the operational point of view, what was done, lessons learned are very important. So what was done, how it was done, safety issues, any other issues should be taken into account, discussed to improve further operations, further design, and the stimulations. So again, not always the formation damage is the result, the reason for the low or poor well productivity, and therefore not always the stimulation will help, as we talked through the lecture. So, for example, here it's kind of some examples when the problem is, for example, when gas well is producing with higher than 200 barrels liquid per million scf, or high water cut, and that might cause the low productivity, low production rate. And who can tell what would be reason here if not formation damage? What would be reason for gas well with the higher than 200 barrels liquid per million scuff or water cut would reduce the production rates from the gas wells. Is there any suggestion? Who is that? Orhan?
Maybe
Samu, if you want, you can say.
you can continue. Let's go.
Okay. Can you hear me?
Yes.
I guess it is relating to hydrostatic pressure coming from liquid. As gas gradient is less, hydrostatic from gas will be less, and liquid will push gas down. That's why productivity will be less, I guess.
Liquid will push gas out. What do you mean by that? Sorry.
Actually, I just wanted to say that hydrostatic pressure created through liquid phase will just prevent production. Will have a negative effect.
Okay. Good start. It is not complete answer, but good start. So yes, heavier hydrostatic from liquid will cause this problem. But what happens because of heavier hydrostatic? Why we see production rate decreased, and in sometimes it's starting to reduce, and in some time it's just stopping, reducing, and then stopping at all production. What happens in the well? So the Orhan has got kind of a correct answer, but not to the fully explained. Slugging is when you have a gas bubbles through the liquid. It is a oscillation production when you have high fluctuations of the wellhead pressure. It's called the result of this heavier liquid hydrostatic called liquid loading, because when the gas well has a high liquid content, then this liquid, because of a heavier hydrostatics, starts accumulating at the bottom hole, and it is increasing the hydrostatic on the reservoir. So the drawdown is between the reservoir and wellbore is reducing, so production rate is reducing, and this accumulation of liquid or liquid loading may come to the point when this liquid column will balance or will be equal to the reservoir pressure, and the gas well will be just will stop producing. Okay, so that's one of the main problems with the wet gas production. Wet gas means gas that is with the high liquid content, and here 200 bubbles. So the liquid may mean both the water or condensate, which also will be can be accumulating in the bottom hole of the wellbore and reduce the production from the well. So gas well, high drawdown, it is a non-Darcy inertial turbulence effects when we produce at high drawdowns. And here, poor tubing outflow for the first problem is the not installing correct tubing size and that is when the velocity of the liquid, when we have a too large tubing, it is in the too large tubing, the velocity of the liquid is much less than velocity of the gas. So gas cannot carry this liquid, and therefore liquid is dropping out from the solution and accumulating in the downhole. So in this case, the velocity string or producing with the coil tubing may be an answer or solution when you decrease the tubing size and the tubing diameter, and the velocity of the fluid is increased and liquid can be produced with the gas. Or you can apply the plunger lift, which we mentioned in the previous semester, if you remember. Plunger lift will help to produce this accumulated liquid and give some time for the gas well to produce naturally, and this process is iterating as the liquid accumulates in the wellbore. Anyway, so the second is the high drawdown or high for the gas wells or oil wells with the high potential, when the friction losses and turbulence near wellbore achieves very high values, and that is creating non-Darcy effect, and it is another a cause of productivity loss. It's actually not productivity loss, it's a production rate loss because of non-Darcy skin reducing the production. And the completion geometrical skin can be because of partial penetration or the low density perforations. So that again creates this non-Darcy effect through each perforation, and that is also maybe a reason for the poor well production rates or reduced production rates. So therefore, you have to study, you have to learn your well, you have to know what is the problem before deciding what a step to be taken next. So just saying that matrix simulation is not the answer. Yes, Sabu.
I would like to ask the question about this first problem, about the gas wells with the liquid production higher than 200. In this case, if we have, for example, dry wells, dry reservoirs, dry gas reservoirs, this is also related, also preferred to this kind of reservoirs, or only wet gas or gas condensate reservoirs. Because in the case of dry gas, we don't have any liquid production.
So that's the problem. That's that's the solution. If you don't have liquid, you don't have this problem. But again, it says this on the second place. It says high water cut, but because dry gas reservoirs may have water cut, may have water production, because this is kind of a normal that any reservoir has an aquifer, and as we produce gas, at some time earlier, sooner or later, the water will come to the wellbore. So it's called water will break through the wellbore. And even in dry gas, you will have this problem because of water cut, not the liquid solve it in the gas. Not only condensates, but also water.
Okay, I understood. Thank you.
Okay, you're welcome. So again, this is the algorithm for the candidate selection. It's just kind of PTA is pressure transient analysis results, so well testing results. So you are going through this algorithm to decide, do we need stimulation or not? What kind of stimulation? We have to calculate theoretical production rate if we can. And that's the reason why the PTA ask the PTA available or not, because PTA will give you a value of skin, and consequently you will have a calculated Q theoretical, and if there is no PTA available, then you will go through this let's say hand calculation, although you can do it on computer as well, but this will not be PTA obtained, but handy calculations of Q theoretical, and then evaluation of the simulation. Will it provide enough incremental oil or not? Yes, Orhan.
Sorry, what is the extension of
No problem.
PTA?
Pressure transient analysis. I said.
Okay.
Okay. This is pressure transient analysis. In other words, it's a well testing. Well testing, again, sometimes people kind of confusing well testing with production testing, which is also called well testing at the well sites or production engineers, because they are testing well through the separators or multi-phase testers. But this production testing is only to determine or define the rates of gas, oil, water, maybe VSMW, which is the water content, solids content in the production fluid, like sand or other scales. So this is the production testing, which is again by the operators, people operating on the well site, is called well testing. But in the reservoir engineering, well testing is the equivalent to the pressure transient analysis, which analyzes the downhole pressures, the behavior of the well bore, so the well, based on the downhole pressures, and identifying the reservoir pressure, the skin of the well, the permeability of the within the drainage zone. So these are the parameters that are the maybe continuity of the reservoir, how long it extends, but at least the well drainage radius can be identified. The well tests, any boundaries like faults or stratigraphic pinch outs may be identified. Yes, Sabuhe.
As I know, this pressure transient analysis is one of the methods of the evolution of the reservoir. But
Yes.
my question is that at which stage this test is implemented on the well? For example, in terms of pressures, before the pressure going to the lower than the bubble point pressure, or even not starting off the production.
Well, it starts with the drilling. The first well test done on the well is drill stem test. When you drill the reservoir and you do the drill stem test. So this test is done on the drill pipes. You kind of facilitate the well with the test equipment and test it to get information about the reservoir, as you said, about the permeability, about the reservoir pressures, about the fluid properties, etc., etc. So it's done at any stage. Actually, from the reservoir engineer point of view, every reservoir engineer would like to have well test data, pressure transient test data every day. But it is not possible because the best test data, test results are achieved by the pressure buildup, which happens during the pressure well shutdown, and therefore the operators will not allow to get too frequent PTA tests or well tests because of this shutdown. Okay, so for the reservoir engineer, for the petroleum engineers, these tests are vital anytime, at any stage, because it provides very direct, almost information about the pressures, about the permeability change, about the boundaries around the wellbore, etc., etc. The longer, for example, shutdown, the longer the longer radius you can investigate, and the longer radius you can get information from the reservoir.
Okay, thank you. But how about the phase of this reservoir? For example, we have a single phase and two phase as we
Doesn't
change
matter.
it. It doesn't affect the result of this test.
Well, it affects, but you have to kind of make correct inputs. What is in the reservoir? What kind of fluids in the reservoir, and how they will behave. Of course, it affects, but you should be prepared to give correct inputs.
Okay.
Okay.
Thank you.
So, as any analysis, if you put in garbage, then you will get out the garbage. So, again, stimulation cycle here, you can see it in your books. So I'm not going to concentrate on this. Here the selection of chemical treatment type. What we should use for chemical, what compositions should be used for the chemical treatment. And here we have some treatment types like acid, inorganic, and solvent washes. It will remove flow restriction like scales or wax, and it's applied in tubing when we have wax or scale depositions in the tubing. So we just circulate through the tubing without injection, without letting it go to the reservoir, and it only will clean the tubing from the scales, from the wax, maybe asphaltenes, and another one is the same treatment will help to remove the flow restriction caused by kill pills, etc. And it might be tubing, open hole perforations, and completion through the completions, the perforations, the low completion area to again circulating through the downhole open and then it will be just left in the wellbore to allow the some those kill pills or other sometimes the solids that we used in perforation or stimulation job, we used those to be solved and produced back from the reservoir. Again, no injection into the formation, and a matrix acidizing. It is what we are learning here to dissolve the rock components, and it is actually near wellbore within the 1 meter or so from the sand face or from the wellbore, and we inject it into the formation below the fracture gradient. And other matrix treatments may be chemical inhibitors squeezed to prevent scaling, solvent and surfactants to remove emulsions, wax from oily wells, etc. Again, we can inject it into the formation, and inhibitors will return with the produced fluid. Okay, this should be in your book. So just go through this fluid selection. What kind of fluids should be used in which cases? We will consider type and so it is very important to identify type and location of the formation damage, where it is, and what are the type of the damage, to choose to select correct treatment type or chemical composition, to correctly select the type of stimulation in terms of, is it going to be acid wash or is it going to be acid injection to remove formation damage? What kind of acid we need? Is it in the sandstones? Is it in the carbonates? These all will dictate the selection of the correct type of treatment. Okay. It's now time up, and what was the question about the quiz? Quiz is going to be held tomorrow during the tutorial hour, 50 minutes. Okay. I instructed your tutorial teachers to give you enough information about that. I don't know if they have done it. Apparently, they have done it to some extent. And what do you know? What do you want to know more?
I want to know about the structure of the question. For example, will it be a multiple choice question or the open-ended questions?
Well, there are multiple choice and essay type, or if you like, open-ended. Open-ended questions are very few. Just I believe it's just 3 of them. In terms of timing, I'm sure you will be. You should be able to complete this test, this quiz in time. I have analyzed your exam conditions, the performance, and so this should be well enough time in terms of timing. The questions are not kind of rocket science. Everything what you have covered, what we have covered from the course material, And so if you have been learning through the semester, there should be just 20 minutes required to complete this quiz. If you are going to look for the answers through the book, then you may spend a little more time.
Elham Malim,
Vale.
should we only work on the LMS or just we can work on the paper, for example, in the open-ended question, then submit in the picture form or I don't know, in Word form?
Well, I'm not kind of expecting any emails with the answers. So preferably use the LMS. I think LMS is just, you have to type in the answer. There is, although I left some optional attachment kind of possibility, but this is optional, very optional. I'm not expecting any attachment, but if you like to draw something, you can draw and attach it, but not email. Okay. You can draw and attach to the LMS, so I can see it in LMS. But I wouldn't expect it. I don't require it at all, and I wouldn't say that it is not welcomed, but kind of it's optional. If you like, you can do it, but I don't require it. So
okay.
The questions are like you just can write through the answer, and if your answer is good enough, I will understand. It's just to test your understanding of material, and also to help you to kind of go through the material during the semester, so you can perceive the material better rather than just preparations during 2-3 days before the exam. Okay.
Okay, thank you.
I was planning to do these quizzes every at the end of every chapter. Sorry, 1 minute. But unfortunately, the conditions, the circumstances didn't allow this. So here we are going to have all 3 chapters that we completed to be covered, but unevenly, meaning that you will have more questions from the first chapter, a little bit less questions from the second chapter, and few questions from the last chapter.
Okay, Elham, thank you.
Elhan teacher, I have one question. The exam will be, the quiz will be the last our production exam. Like will we go through the